Okay, so welcome to the sixth class of our computer architecture and organization. Okay, so in this class we are going to show the slides. Yeah. So in the last class we have discussed about pipelining, isn't it or not? So in this class we are going to discuss about the cache memory. So what is mean by a cache memory? What does it mean and what is its uses? All these things we are going to discuss in this particular class. Okay. So what is mean by a cache memory? So what is mean by a cache memory means, see, actually before discussing this topic, we will discuss the general operation of a computer. Okay, so as we have discussed in the previous classes that computer has two memories. First one is primary memory and the other one is secondary memory. What is meant by primary memory? Primary memory is nothing but the inbuilt memory. The inbuilt memory or the memory that will be present during the at the time of your purchase. When you purchase itself, you will get some memory along with the computer that will be referred as primary memory. The secondary memory is the memory that will be interfaced externally by using any pen drive or CD or DVD or any hard disk that is interfaced externally. It will be referred as secondary memory. Okay, it is well and good. So what is the purpose of this cache memory and what does it mean? So cache memory is nothing but it is one of a memory unit. It stores only small amount of data. What is the data it is going to store generally means, generally if you are performing any operation, so what is the thing you used to do? So how can I explain means, before I go into this concept, I will just explain one example. See, you are using your internet. Okay, so whenever you are having your own PC, think that you are having your own PC and you are using the internet very frequently. So whenever if you log in, if you open Google Chrome and whenever if you try to what you call enter some URL, enter some website name, then automatically whenever if you click on a Google Chrome, what is the thing you can observe? Obviously there will be some list of websites that will come to you which you have used them very frequently. For example, let me explain you. So for example, consider this is my what do you call Gmail, and whenever I try to open this Google Chrome initially, so here you can observe J into CEO previous question papers, J into R13 CEO, something you can observe. Okay, these are the things what I have used very frequently, and these are the things what I have used recently, isn't it or not? So whenever I open a Google Chrome and if I want to search anything, then obviously I can see some list of data. These may be the things what I have searched frequently, or these may be the things what I have searched recently. So here also, so what is the purpose of that one means? So it will make me my task easy, because mostly here also you can see some of the things what I have searched very frequently. What are the things you can see? Gmail, my inbox, Google Classroom, Google Drive, all these things. So because I am using them frequently, those are present here in the here itself, so that I can access them very easily. So that is the concept that is present. The same concept is cache memory concept. I think you all are, now you have understood about this very clear. Okay, you can see it in your computer also. Whatever you have searched frequently, or this is the best example what you can see. Here, if you observe, there is a mail which I am opening very frequently. This is the Google Classroom where I am uploading my videos or whatever it may be. So you can easily see these things whenever I open the Google Drive or Google website. So here also the cache memory means, so here also the cache memory is nothing but the memory which will be used very frequently. It is a very less memory. It consists of the data which the user is using very frequently. So what is the advantage means? It is the fastest memory. See, you can in the next slide you can even see the its diagram also, or where it is placed. Here in this architectural diagram, you can easily observe that before cache memory, or if the cache memory is not present, initially, what is the task that is going to happen means, if if the CPU wants any data, it has to search from the primary memory. Okay, so primary memory may be up to 400 GB or 500 GB. Sometimes it may be 1 TB also. Depends upon your configuration of a computer. Okay, so obviously it will become a very difficult task and also time consuming task for a processor to search the required data from this huge primary memory, isn't it or not? So searching the required task or required data from this huge primary memory is going to be a very big problem for our processor. So in order to overcome from this problem, there is a flexibility that is provided. That is nothing but cache memory. What is meant by this cache memory means, whatever the data a particular user is accessing frequently, okay, whatever the information or whatever the data the user is accessing frequently, that data will be stored in the cache memory, so that whenever user wants to access, he need not to whenever user wants that particular data which he is used frequently, he need then the processor need not go and search in the primary memory, entire primary memory. First of all, it will search in the cache memory. If it is present in the cache memory, then automatically the processor will take the data. Okay, the processor will go to the primary memory once if it is not present in the cache memory. Okay, so obviously it will reduce the time taken in order to access the or search for the given data. So it will increase the speed of operation, which in terms increases the performance of the system. Because if you want to buy any system, what is the first parameter you are going to see? The performance of the system. That means how fast it is operating, how speed it is responding, isn't it or not? Because nowadays every system or every laptop has the same configurations. That means the camera quality or the size of the screen, laptop or touchpad, whatever it may be. Nowadays all the PCs or all the laptops are mostly having the same configurations or same sizes, whatever it may be. But what is the so if you want to buy any particular laptop or PC, what is the thing you will see initially means how fast the processor is responding. Okay, so here also, due to this cache memory, it enhances the speed of operation, because it will store the data which is being executing or which is being accessed by the user very frequently. Okay, so that data will be stored in the cache memory. So whenever an user asks for a request or searches for a data, then the CPU first search that particular information is present in the cache memory or not. If that particular information is not present in the cache memory, then only the processor will go for the primary memory and searches here. Okay, so it will increase the speed of the operation, hence it will increase the performance of the system also. Okay, next, once the cache memory is full, that means for example it can store only 10 websites. Okay, once the 10 websites are filled, then obviously what is the thing that is going to happen means, what the old data among the 10 instructions or 10 websites, what is the old one that is updated, that will be removed and the newer one is going to be placed here. Okay, so this is the phenomena in the cache memory. So what is its definition? You can see it is an extremely fastest memory. Why it is called fastest memory means, here it is only of small memory, so searching of this particular cache memory will be very easy by the CPU. It is not a big memory as like primary memory or secondary memory. So searching of any instruction or anything in a cache memory is very easy. Okay, so obviously the cache memory is the fastest memory. So what is the thing it is going to store in the cache memory means, it will store the frequently requested data. That means here in the previously I have showed so whenever I opened Google, then what is the whenever I want to try something, then obviously it is showing some icons before. So below, what they are showing means Gmail, Google Drive, like that, because those are the things what I am accessing very frequently, isn't it? Or not? If not, I will show you once again. So here, whenever I open this Google, then here it is showing Gmail, inbox, Gmail, Google Classroom, like this, because these are the things what I am accessing or using very frequently. So simply to say, here also these things are stored in the cache memory, like that. You can think of it. Okay. So that is about the cache memory. It holds the frequent request data. One is frequently requesting data and the instructions, so that they are immediately available to the CPU when needed. That means no need of going to the server, searching, or here there is no need of going to the primary memory and searching in the entire primary memory. Like that things, there is no necessity. Okay, so that it will increase the performance of the computer, because you can get the data in very less time. That means accessing time is very less, so it will increase the speed of the operation. Whenever the speed of the operation is increased, automatically it will increase the performance, because the what is the main criteria one will see to analyze the performance of a computer is its speedness, how fast it is giving the output, isn't it or not? So that is the purpose of this cache memory. Okay, so I think you all are very clear. Okay, so this is about third generation. See, once again, I will go to the previous slides, because from where we have started and from where we have moved, I will give you one clarity. Because what are the topics we have covered, these will all come under the third generation. In the third generation, you are having pipelining, parallelism, all these features. Okay, for that purpose, in order to know about those things, we have discussed all these topics. Okay, so I will just move to the previous slides once again, and I will give you a connection. Okay. So, see, initially we have started with first generation computers. So this is first generation computers, and next we have moved to 1 minute slideshow. Okay, so this is the first generation computers. From first generation computers, we have moved to von Neumann architecture, because in first generation computers, what we have discussed there, they have used the von Neumann architecture. So as there is a point that is mentioned, so in order to know about what is meant by von Neumann architecture, I have given the clarity. So what is meant by von Neumann architecture, and we have even discussed about what is meant by von Neumann architecture and what is meant by Harvard architecture. So basic difference between them, all these things we have discussed. So as their initial computers, there they have used the von Neumann architecture, where there is no separate memory for program and data. There is a common memory in von Neumann architecture. So accessing the data is going to become very difficult task. Okay, so this is first generation. So in first generation, they have used vacuum tubes. Next, we have moved to the second generation. Whereas in second generation, instead of vacuum tubes, they have used the transistors. So with this use of these transistors, there is a vast development. There is a vast, what you will call improvement. Okay, so the size of the computer has been reduced from a big classroom to a EDC lab table setup. Okay, simply you can say a setup in our EDC lab. So there is a lot of change in the size, and there is a lot of change in the power consumption. The number of components are being reduced in the second generation. Okay, so in the second generation, they have used first time they have implemented the high level languages. In first generation computers, there is no high level language. Whatever the programming that was written, that all written by using the machinery language. Machinery language means binary language in the form of zeros and ones. Okay, in the second generation itself, they have implemented the high level language. Fortran is the first high level language. Okay, and there are separate IO processors which works in parallel. So that means parallel operations has been taken place started in the second generation. Okay, so that is about the second generation. So as there is parallel operations that are going to take place, so it increases the speed of operation and also the performance compared to first generation, because here there are 4 members, they are doing their works parallelly or independently, so that they can do a lot of work. Because I can do some work, my colleague, there is some other friend, he can do some other work, another colleague can do some other work, so that there will be a lot of work will be done by us. If not, all the if all are doing the same work, then there is no use, no, because one person is doing some work, rest of the 3 persons used to sit idle, isn't it or not? So in second generation we are having separate IO process which helps in the parallel execution. Okay, next from that, so these are the transistors that are used in the second generation. So the second generation is from 1956 to 1963. Later we have moved to the third generation. So in third generation, small scale integrated circuits were used. So by using these small scale integrated circuits, there is a drastic change in the size of a computer compared to the second generation, and number of components are also reduced, and it also increases the speed of operation, and power consumption is also reduced to a greater extent. Performance is also increased. So what is an IC? So this will be an IC like this. Okay, so these ICs were implemented or used in the third generation. Third generation lasts from 1964 to 1971. Okay, so in the third generation, where they have mentioned some special features like micro programming. Sorry. So micro programming, here you can see parallelism and pipelining. Micro programming, parallelism and pipelining, and cache memory, virtual memory. Okay, so these are the things they have mentioned or they have implemented in the third generation. So we have discussed what is meant by micro programming, what is meant by parallelism, what is meant by pipelining, cache memory. I think I haven't discussed about the virtual memory. Okay, I will discuss in the next classes, no problem. Okay, so these are the extra features that are added in the third generation compared to the second generation computers. Okay, so from here we have started discussing about all these rest of the slides. So in the third generation, they have mentioned micro programming, parallelism, pipelining. So till now, and cache memory, till now we have discussed about them. See, this is about pipelining. Pipelining means executing of multiple number of instructions, or a technique used in the advanced where a computer begins executing a second instruction before the first instruction has been completed. That means several instructions are in pipelining simultaneously, each at different processing stage. That means if you think there are 5 stages, one instruction will be in the fetching stage, second instruction will be in the decoding stage. See, here is without pipeline. Now this is with pipeline. If first instruction is in decoding, or here we observe the first instruction is in output stage, you can observe second instruction in E stage, third instruction fetching stage, output fetching stage, input decoding, input fetching. Here you can observe all the 5 instructions are being executing, but the stages may be different. One instruction is in input fetching, another one is input decoding, other one is output fetching, input execution, output writing, or something, whatever it may be. Or if you don't bother about all these things, just think that there are 5 cycles like these things. First one is fetching the instruction, decoding, executing, memory, and write cycling. Okay, here also if you observe, due to the pipelining, one is executing, other will be in the memory stage. Here, so here it is, if you consider this is in the execution, this is in the memory, and decoding, execute, writing, decoding, fetching, like that. Okay, that means here you can observe 5 different instructions are being operating. Their stages may be different, but they are executing at a single clock cycle. Here also you can observe as the first instruction is over, if there is any instruction number 6, it will join here. Everywhere if you observe, there will be n number of instructions that will be executing in parallel. This will increase the speed of the operation. That's what we have discussed in our previous classes, isn't it? Okay, so this is the advantage of pipelining. So improves the performance, increases the speed of operation, and all these things. Okay, next, what is meant by micro programming? This also we have discussed. Micro programming means whatever you are writing a code for our microprocessor. So microprogramming is a low-level program. That means the code will be developed in the form of binary language. That means in the form of zeros and ones. All the instructions are should be written in the machine language. Machine language means it's a binary language. It should consist of ones and zeros. There won't be any English and there won't be any hexadecimal number system. Everything MOV, if I want to write any MOV instruction, there will be a predetermined binary value for each and every instruction. Okay, that you need to present here. So that is called micro programming and micro coding. Micro programming is nothing but process of writing micro code for a microprocessor. What is meant by a program? Program is nothing but group of instructions. That will be referred as code. Okay, so micro programming is nothing but writing a micro code. Okay, for which? For a microprocessor. For a microprocessor, you are writing a code. Code is nothing but a programs. Program is nothing but set of instructions. That means obviously what you are doing, you are writing an instructions for a particular microprocessor. But the code what you are writing, the code is nothing but group of programs. Program is nothing but set of instructions. That means altogether what is the thing you are doing? You are writing some instructions. The instruction should be in the machine level language. What is meant by machine level language? It is a binary language. Binary language means in the form of zeros and ones. That means micro programming is nothing but developing a program in a binary language. That means in the form of zeros and ones. That will be referred as micro programming. Is it clear to everyone? So that is micro programming and microcode. Okay. So these are the features: pipelining, microprogramming, parallelism, virtual memory, cache memory. These concepts were included in the third generation computers. Now we are moving into the fourth generation computers. Frankly saying, now we are in a fourth generation era. Okay, so no doubt there are fifth generations, ultra large scale, giant large scale integrated circuits are there, but they were not present, I think, mostly in the India. They may be present in abroad, and somehow they may be used in space applications or whatever the applications. But now what we are using, that means the laptops or what we will call the PCs, what students and the faculty are using nowadays, or that are present in our laboratory, simply to say whatever labs in our colleges, those will come under, mostly they will come under the fourth generation. That means whatever the computers that are available in our computer centers, that means either it is in computer center lab or our MPMC lab, whatever it may be, those will come under, mostly come under this fourth generation. Here, so instead of small scale integrated circuits, we have used VLSI, very large scale integrated circuits. Okay, so there may be, see, as per one classification, after small scale there are medium scale, afterwards large scale, then comes the very large scale. But as per this textbook, what is the textbook I am following? Morris Manum. Okay, this is a standard prescribed textbook. So they have considered small scale, medium scale, large scale as one generation itself. Okay, now as per this textbook, the fourth generation is VLSI technology, very large scale integrated circuit. Okay, what is meant by this one means, see, if you observe carefully, if you have any desktop, that means what you call desktop or laptop, mostly if you have desktop and if it is of assemble type, during the assembling time, if you observe, so if you'll ask for Intel i3 processor or i5 processor. Okay, did you observe that processor? If the processor contains that entire box, మీకు డబ్బా కనపడింది కదా CPU, దాని మొత్తం ప్రాసెసర్ ఉండిద్దా? No, no. So the processor will be of very little bit size, isn't it or not? Okay, so the Intel processor will be of very little bit size. 1 minute. So see here you can see multiple number of images now. So whenever they are trying to, whenever you buy any desktop in an assembled model, and whenever you buy any so whenever you buy any desktop in an assembled model, so if you observe that particular, if you see, you can see this particular what you will call microprocessor. Okay, so that will be of this one. It will look like this, simply like this. So you can hold it on your palm also. Okay, so why I am specifying like this means here, if you observe now in the fourth generation, you the entire microprocessor is being fabricated on a single silicon chip. So this is a silicon chip where our microprocessor has been fabricated. So that is the advanced technology. Due to this very large scale integrated circuits VLSI technology, which is fourth generation as per this textbook. As per your basic knowledge, after the small scale integrations, there is medium scale, later on large scale, later on very large scale. But as per this textbook, they might have combined all these things, small, medium scale and large scale as single technology, small scale, medium scale and large scale as third generation, and fourth generation we are having very large scale integrated circuits. So in these circuits, if you can easily observe this figure. Okay, here the entire microprocessor is being fabricated on a single silicon chip. This is a single silicon chip where you can see some gold patches or something. So you cannot understand what these things. You can understand only by using. You can observe what are these by using only a microscope. Okay. So by using this VLSI technology, the entire microprocessor is being fabricated on a single silicon chip, so that it reduces the computer size to a very, very greater extent. So that you can nowadays, if you observe, you are having tablet PCs also. First of all, it took in first generation, a computer took the size of a big room, but now the size of a computer has been restricted to your palm. Isn't it or not? The tablet you can hold with your palm and you can operate. So that is the advancement. This advancement took place due to this VLSI technology. Okay, so that is the advantage of this very large scale integrated circuit technology. So here the process having much more features. As you can see, the size of the processor has been reduced to a greater extent. Its power consumption also reduced. The size occupied by it also is reduced to a greater extent. Speed of operation is also increased, because whatever the components where you need to transfer the data, they all are present side by side. So there is no bothering of going to a larger distances to get the data whenever required. So it will increase the speed of the operation. As the size is very small, power consumption is very less, it occupies very small size. So these are the advantages of this VLSI technology. That means the process using the fourth generation. Okay, so complete processor fabricated on a single chip. That's what I have shown in the previous figure. Okay, so this will be referred as microprocessor. Generally, the definition of a microprocessor is CPU on a chip. If the entire central processing unit is fabricated on a single chip, it is called a CPU. Okay, so in VLSI technology, it is possible to fabricate the entire central processing unit in a single chip, which is called as this, which is possible with this VLSI technology. And the process what we have used here, they are having more features and more memory on a single chip is possible through this VLSI technology. Because if you can observe, a processor is being placed in a small IC, which small silicon chip, which you can hold by using your palm, or which will be holded or which can be placed in your palm. That means very small size. So you can observe the size of a memory device, because okay, so with this much size memory chip, you can store some 64 GB of data also, isn't it or not? So when you purchase any memory die, that will be of this much size, but the entire thing is plastic or metal. The required memory chip will be black shape, which is very, very small size, isn't it or not? So in that small chip, we are able to store some 32 GB or 64 GB of data, or even 128 GB of data. That is possible only due to VLSI technology. In first generation, In order to store 1 MB, 1 megabyte of data, you need this much size floppy disk or magnetic disk of this much size, 1 MB of data. But now with this much size, though the pen drive looks this much size, all the thing is metal or a plastic. The chip will be black colored chip. It will be of only this much size, where you can store easily some 128 GB of data or more. So that is the advancement that took place due to this VLSI technology in the 4th generation. Okay. So this is the basic 4th generation computer. These computers are present in our labs and everywhere, isn't it or not? In our PMC lab or wherever you go, you can see these kind of 4th generation computers. Okay. Okay, this is the important topic. One more important topic. What you need to discuss now. Okay, Risc and Cisc. Okay, one more important question, and it will be very much useful for your interview part. Whenever you face any technical interviews in CAO or MPMC, microprocessor and microcontrollers, that means whenever a EC person goes to embedded system side, then this is Von Neumann and Harvard architecture, Risc and Cisc. These are the important differences what they used to ask. Okay, so first of all, what is meant by CISC? So this is the CISC stands for CISC stands for Complex Instruction Set Computer. Complex Instruction Set Computer. RISC stands for Reduced Instruction Set Computer. Reduced Instruction Set Computer. Okay, the basic difference between CISC and Risc are initially, that means first generation, second generation, the initial computers are developed by using this CISC, that means not okay, by using this CISC technology. Simply to say, the second and third generation computers, not first, because the first generation computers, there is no high level language, there is only machine language. Second and third generation computers are what you will call, they are implemented or they are developed by using the CISC technology. The full form of CISC is Complex Instruction Set Computer. That means this is the initial way of writing a programming. Okay, this is the initial way of writing a programming. Here the instructions are very complex. So in the name itself, complex or complete instruction set computer. Generally we don't use complete, generally it is complex instruction set computer. Okay, here the instructions are very complex. That means they are not easy to learn by any user. They won't be like MOV, ADD, SUB, what we are using nowadays. Nowadays we are using very simple programming language like ADD, SUB, MUL in our microprocessor and some other subjects, where the user can easily understand. If I write any instruction ADD, anybody who have basic knowledge can know that it is going to perform some addition, isn't it or not? They may don't know where the data result is going to be stored and how they are going to add it. Like that they may not know, but they can easily identify what is meant by SUB instruction. If I write SUB, anybody can know that it is going to perform some subtraction. If I write MOV, you can easily understand it is going to perform some move, MOV. That means it is moving. Okay, like that. So this is Risc. But initial days we are having CISC. That means complex instruction set computers, where the instructions are not simple. They are very complicated. It is very difficult for a particular user to learn this CISC architecture, CISC instructions. Okay, that means learning of an instructions will be very difficult task to a learner. Okay, so that for learning a particular these instructions, it will take a lot of time for him. Okay, and one more thing is the instructions are not of equal size. That means one instruction may take a single clock cycle for execution, and the other instruction may take 2 to 3 clock cycles. That means first instruction may have only fetching and execution. Second instruction may have fetching stage, decoding stage, execution stage. Third instruction may have fetching, decoding, reading, execution. And the another instruction may have fetching, decoding, memory read, memory write, execution, and memory write. That means it may have some five stages. That means the size of the instruction is also not same in the Cisc. Okay. Due to this the instructions are not simple or easy to learn by any learner. That means writing a program in Cisc is very complicated, because it is very difficult. Not all the people prefer to learn this particular Cisc. Okay. And what you will call, and one more thing, so it is very difficult to write the program, and the instructions are also not of same size. That means one instruction may have only 2 cycles, fetching and execution. Second may have fetching, decoding, writing, and execution. Third may have 3 clock cycles, and the other may have 4 stages, like that. Okay. Due to this uneven size of the instruction, pipelining phenomena is not present in the Cisc. So we have previously discussed the advantage of pipelining. Now, with the pipelining, the number of instructions that are required to execute, the number of cycles that are required to execute an instruction have been reduced to a greater extent due to the pipelining. We have seen the differences very clearly in our previous slides. Okay. Due to in the Cisc processor, there is no pipelining concept, because the instructions are of different sizes in the Cisc. Okay, so there is no pipelining phenomena. So obviously, it will take a lot of time for execution. Okay, it will take a lot of time for the execution. So the speed of the processor is very slow, which in result decreases the performance of a computer. So that is the Cisc. So in the 4th generation, in order to overcome the drawback of the Cisc, so they have implemented the Risc architecture. The full form of Risc is Reduced Instruction Set Computer. See here, the name itself indicates reduced instruction set computer. But one more advantage of Cisc is, see, before Risc, the advantage of Cisc is Cisc does not have much more number of instructions, though the instructions are very complicated. So here more addressing modes. Okay. The advantage of Cisc is, though the instructions are very complicated, but for writing the same program in Cisc and Risc, okay, Cisc takes less number of instructions for writing any program compared to Risc. That is the advantage of Risc. Okay. Now, okay, we'll discuss later the differences. Now we are moving to the Risc. Risc means Reduced Instruction Set Computer. Reduced instruction. In the name itself, it indicates the instruction complexity is reduced. That means in a Risc instruction set, a learner with minimum knowledge in English can easily, with minimum knowledge in English and mathematics, that means if he passed 10th class, okay, that is sufficient. Or if he belongs to some 8th class and 9th class, that's also sufficient in order to learn the Risc architecture, because here the instructions are very easy. Like they will be like ADD, that is used to addition, perform addition. For performing subtraction, the instruction will be SUB. For performing multiplication, the instruction used to be MUL, first 3 letters. For performing the division, it will be DIV, first 3 letters. That means a user, a learner who don't have any knowledge can easily learn this instruction even on his own without any help of the others. So the instructions are very easy to learn, and each instruction takes the same amount of clock cycles. That means each instruction is of same size. Each instruction is of same size. That means each is having same amount of stages. Whether it may have 3 stages or 4 stages or 5 stages, whatever it may be, all the instructions that are present in that particular Risc instruction, they are of equal stages. For example, if you consider MPMC 8086 microprocessor, so that's what you are going to discuss in the next session. MPMC, microprocessor and microcontrollers. 8086 microprocessor has three-stage pipelining. Three-stage pipelining. Whatever the instruction you write, okay, every instruction is going to undergo those three stages only: fetching, decoding, and execution. There won't be one stage for particular instruction, and there won't be three stages for other instruction, and five stages for some other instruction. Just like in Cisc, that is not present in the Risc. Whatever the instruction may be, all the instructions are having same amount of what you will call cycles. That means they are of equal length. Simply to say, all the instructions is of equal length, so that you can perform this particular operation. What is the operation you can perform? You can perform this pipelining. Okay, because each are having same length, you can perform the pipelining, which in turn increases the speed of the operation. So that is the advantage of Risc. And the instructions, so the instructions are very simple in Risc. Next, each are of same length, so that you can perform, you can use pipelining concept in the Risc, and they are easily, user can learn them very easily. But the major drawback of Risc is, see, that's what I have told previously. In order to write a program, okay, if you write that particular program in Risc and Cisc, the number of instructions that are required will be less when you opt for Cisc rather than the Risc. That means when you opt Cisc technology, complex instruction set computers, you can develop a program in 10 steps. But if you want to develop that same program by using Risc instruction set, it may take some 15 or 17, sometimes even 20 instructions also. Though the instructions are very simple, but the disadvantage of Risc compared to Cisc is it will take much number of instructions for developing a same program. Okay, so that is the major drawback. So here you can see the differences between Risc and Cisc. These are only a few differences. You can get much more differences when you go through a internet or somewhere. Basically, Risc means reduced instruction set computer. Cisc means complex instruction set computer. Here, see, number of instructions in Risc are less. Instructions of same set with few formats. Here, multiple instruction sizes and formats. See here, the sizes are of different sizes and different formats. The instructions here, they are of same size. That is the thing what you need to think. Okay. Next, in Risc you need more number of registers, but here less registers. And Risc, see, addressing modes I haven't discussed till now. Okay, that I will discuss in the next unit. Here, less addressing modes are present in Risc, but compared to Risc, number of addressing modes are more in Cisc. Okay, here it is complexity, it is easy. Instruction takes one cycle time. Here, that's what we have told. Every instruction takes equal amount of time in Risc, but here the different instructions take different amounts of time. As all takes one cycle of time, pipelining is possible in Risc. Here there is no pipelining. Okay, so these are some of the differences, but more you can get if you go through any what you will call the net websites and nets or any textbooks. Also you can get still further. Okay, so this is the overall introduction of the first unit. I think by this class the first unit is almost completed. Okay, if there are any topics we will discuss in our next slides. Okay, thank you.